So today's lesson is on the quotient rule. And what we're going to start is with a little investigation. So we're going to find the derivative of these functions using the product rule. So what we did yesterday. So basically, I'm going to change these into negative exponents. So this one would be x to the power of -1. And then if I were to find the derivative, well, actually this isn't using the product rule. This one will be using the product rule. This would be just negative x to the -2, which is -1 over x squared. Okay, and you can extend this idea to this one. This one would be -1 over x cubed, oh sorry, -2 over x cubed. And this one would be -3 over x to the 4. So you can sort of start to see a little pattern there. And let's do one that's a little bit more complicated. So this one we are going to need the product rule. I'm going to do this one on the side where I have a little bit more space. So I'm going to rewrite p of x as 3x minus 4 all times by x squared plus 5 to the power of -1. So if I were to find p prime of x, okay, well let's do this. Find the derivative of the first bracket, so it's just 3, and multiply by the second bracket. Then we're going to add just the first bracket and the derivative of the second bracket. So we're going to need to multiply by -1. I'm running out of space here. I'm just going to go over top of all the script here. -1 times what's in the bracket, x squared plus 5. Subtract 1 from the exponent. And then we're going to multiply the derivative of in that bracket, which would be 2x. All right, so we can clean this up a little bit. So 3 over x squared plus 5 plus we have -2x. So let me actually just subtract. Minus 2x times 3x minus 4 all divided by x squared plus 5 squared. All right, so to get a common denominator, I'm going to multiply this fraction top and bottom by x squared plus 5, like so. And then I want you to look at what we're left with. So we have 3 times x squared plus 5 minus 2x times 3x minus 4, all divided by x squared plus 5 squared. So if you look at this and compare it to the original function p of x, it looks like we have the derivative of our numerator multiplied by the denominator, and then we subtract the derivative of the denominator multiplied by the numerator, and then we just divide by the denominator squared. So does this always work? Well, I have a bit of a proof down here we can go over. So let's say you have a function h of x, and it just equals f of x divided by g of x, as long as g of x isn't 0. Well, what I can do is rearrange this, multiply both sides by the function g of x, and I get this. Now I can apply the product rule and figure out what f prime of x is. So this is just using the product rule. We get this. Okay, Well, now let's bring this term, since I want to solve for h prime of x, we'll bring this term over to the other side of the equation, and so we're subtracting it. And then divide both sides by g of x. So now we've isolated for h of x, but we still have, h prime of x, but we still have h of x right there. So I know h of x is this, so I'm just going to substitute that in there. And then to get a common fraction over here, I multiply this by g of x over g of x. And then I can bring that common fraction into the denominator and square it. And I'm left with what we call the quotient rule. And so the derivative of h of x, so h prime of x, is find the derivative of the numerator, multiply by the denominator, then subtract the numerator by the derivative of the denominator, and then divide by the magnitude of the denominator squared. So let's try this one again. This is the exact same one we just did over here. And we got this, except I didn't simplify it yet. We can do that. But using the quotient rule, we can get this directly. So h prime of x equals, so we're going to do the derivative of the numerator. So we just get 3 multiplied by the denominator, so x squared plus 5. And then we can subtract the derivative of the denominator, so we're going to be left with 2x times the numerator, 3x minus 4, all divided by x squared plus 5 squared. And that's exactly what we had right here in this step. So we did that in just one step. So it is quite convenient, the quotient rule. Now we should probably simplify this a little bit. So if we expand, we'll get 3x squared plus 15 minus 6x squared plus 8x all over x squared plus 5 squared. Alright, so 3x squared minus 6x squared gives us minus 3x squared. And that's as much as we can simplify that. So plus 8x plus 15 all over x squared plus 5 all squared. There we go. So the first practice problem, we have determined the derivative of the following function at a given value of x. So in this case, x equals negative 3. So first let's figure out what the derivative is. We're going to use the quotient rule to help us. So f prime at x equals, okay, let's start by finding the derivative of the numerator. So we're just left with 3. Multiply that by the denominator, so x plus 5. Then we're going to subtract the numerator, 3x plus 2, and multiply by the derivative of the denominator, which is just 1, right? X plus 5. The 5 will be 0, and the x is just 1. And then divide it by the denominator squared. And we're just going to clean it up a little bit. So we'll expand the numerators to give us 3x plus 15 minus 3x minus 2 all over x plus 5 squared. Alright, so 3x minus 3x, that just goes away for us. And we're just left with 13 over x plus 5 squared. Alright, now the question is asking to find it at negative 3. So we're going to find f prime at negative 3. And that'll give us 13 over negative 3 plus 5 squared. Negative 3 plus 5 is just 2, and 2 squared is 4. So we get 13 over 4. Alright, so example 2 says determine the equation of the tangent to y equals 2x over x squared plus 1 when x is 0. So to determine the equation of the tangent, we're going to need to know the slope at that point. So we're going to need to figure out what the derivative is at 0. And we're also going to need a point. Right? Our point would be 0 and whatever the y coordinate is. But if we substitute 0 in here for x, we get 0 divided by 1. Right? So we already have a coordinate 0, 0. So let's figure out what the derivative of this is. Now, since it's given as y, I'm going to use Leibniz notation. I'm going to do dy by dx. And then apply the quotient rule. So the derivative of the numerator is 2 multiplied by the denominator x squared plus 1. Subtract the numerator, multiplied by the derivative of the denominator, which is 2x, all over the denominator squared. Alright, so we can clean it up a bit. So we get 2x squared plus 2, and this is minus 4x squared all over that denominator squared. Alright, so 2x squared minus 4x squared, so we're just left with a negative 2x squared plus 2 all over x squared plus 1 squared. Alright, and now I can see that at x equals 0, when x is 0, we're left with, well, that first term is 0, so we're left with 2 over, well, that's a 0, and 1 squared. So 2 over 1 squared, which is just 2. So that's our slope m. So now I can figure out the equation. By using the equation of a slope. So m equals y minus y naught over x minus x naught, where m is 2, and our coordinate is 0, 0. So y minus 0 over x minus 0. Rearranging that, you just get y equals 2x. So there's the equation of our tangent, y equals 2x. Okay, so the last example says determine the coordinates of each point on the graph of this where the tangent is horizontal. So the tangent is going to be horizontal when its slope is 0. So what we need to do is first find the derivative of this function, set it equal to 0, and find out for what values of x does that tangent equal 0, or does the slope equal 0. And then we can figure this out. It might be for 1 or more. So first step first, let's find the derivative. So f prime in x, and we're going to use the quotient rule. It's going to be the derivative of the numerator, which is 2, times the denominator, root x. Subtract the numerator, 2x plus 8, right, times the derivative of the denominator. And you can think of this as x to the 1/2. So first multiply by 1/2 times x, and subtract 1 from the exponent. So 1/2 minus 1 is negative 1/2. And then divide that by the denominator squared. So the root of x squared, which is just going to give us x. Okay, time to clean things up a bit. So here we have 2 root x. Subtract, so we have 2x plus 8. So the 2x plus 8, and then what we can do is divide that. So this is 1/2, so we can put a 2 on the denominator, and we can write this as x to the 1/2, which is just root x. And all of that is divided by root x squared, which is just x. So now we're going to need to subtract these fractions, and to do it, this one I am going to multiply by 2 root x and divide by 2 root x. I'm going to have a 2 root x here, and I'm going to do the same thing here. So that's going to give us 4x. Then we have minus 2x. Okay, and remember this is like this, so then we have minus 8, all divided by, I don't know why I just wrote 2 root 2, that should be 2 root x. Okay, so we have the x, and then we have our 2 root x. Alright, so 4x minus 2x is just 2x, and then minus 8. So 2x minus 8, but we can factor out a 2 to have x minus 4 all over. We have the 2 there. I'm going to pull it out at front because you can see I'm going to cancel it. X times the root of x. When we cancel out the 2's, we just get x minus 4 all divided by x root x. Alright, so there's the derivative, f prime at x. And remember, it tells you the slope of the tangent at any point of x. And we want to know when that slope equals 0. So let's set that equal to 0 and solve for any value of x. Well, there's only one possible thing here, right? If we multiply both sides by x root x, we just get x minus 4 equals 0, or x equals 4. So at the coordinate x equals 4, the slope of the tangent to this function is 0. So it's a horizontal tangent. But it asks for the coordinates. So we have our x coordinate, it's 4. So then we need to figure out what the y coordinate is. The y coordinate would be f at 4. We're just substituting 4 back into our original function. It's 2 times 4 plus 8 over the square root of 4. So that's 8 plus 8 is 16 divided by 2 is 8. So, therefore, horizontal tangent at these coordinates, 4 and 8.